Right. So following the our dynamics lessons, in this lesson we'll see something that is going to be very relevant for our course, and those things are called free. This thing is called free body diagram. We have already seen what this thing is, okay? But this thing is basically the reduction. So it's a reduction from a complex system into a more simplified version. So we reduct our system to get something more simple. And it's going to help us visualize. It's a tool that helps us visualize forces acting on a body. Okay? So it helps us visualize the forces acting on a body. So for example, let's see something like this. It's yeah, something like that. Okay, so we have a box here. Okay, so we have a box, and in this box we are pulling, okay, with some force. So let's call this force 1, okay, and we are pulling on that box with that force. The free body diagram or free body representation of this system right here is we condense all of this. All of this gets condensed. All of the mass, which is this is our system. This is what interests us right now. All of this gets condensed into one point, okay? So all of that is one point, okay? And once we have that point, we need to start figuring out what forces are acting on that point, okay? It's a reduction. We're reducing all of these complex information into a more simplified version of the same system. We're visualizing the forces that act on this body. So the first and most evident force is this one right here. This force, force 1, it's going in this direction over here. Okay, this is force 1. And force 1 has this angle right here, theta. And that angle is exactly this angle right here. Okay? Why? Because this force is running parallel through to this surface. Okay? So this angle right here is exactly this angle right here. So we can say that force 1 has this angle right here. Okay, what other forces are acting on our body? Well, let's remember that since we are on Earth, any mass whatsoever, so anything that has weight. Okay, and this is very important for you guys to understand the difference. Mass is the amount of particles that any given thing has. Okay, so it's a quantity of how many particles that thing has, and weight is a force of attraction. Remember that we saw this with Newton's gravitational equation. So weight is a force of attraction. So in SI units, the unit for force is Newton. And how do we get the weight of an object? Well, weight is equal to the mass times the acceleration of gravity. So for example, if we have a mass of 10 kilograms, we multiply that by 9.81 and we get 98 newtons. Okay? So remember, weight is always mass times the acceleration of gravity. And weight is always a vector that is going towards the center of the planet. Therefore, weight is another force that is acting on the object, and it's always going downwards. Always going downwards. So this is weight, and this is equal to mg. Okay? So if this is a frictionless system, so frictionless means that there is no friction. So for frictionless system, okay, that means that there is no friction. That means that this thing right here glides along the surface. let's remember what friction is. So let's take a microscopic look to this interaction right here. So if we look at that interaction, we will actually see that that solid is not necessarily solid, but it's made up of many, many different bumps. Okay, so this is the box. So this is the box. And down here we'll have the plane. So on the interaction between these two things, okay, there are many different bumps. Okay, bumps right here, like that, like that, like that. So the friction between these two bodies is when these two things actually interact with each other. So friction is none other than a sum of forces, of all of the forces that interact here. Okay, all of the forces that go in this direction right here, due to the fact that these two things are interacting with each other. Okay, that is what friction is. And friction is calculated by a coefficient of friction called mu. This could be both static or dynamic, and I'll make a video on that, and multiplied by the normal force. The normal force has to do with Newton's third law of motion, that every action comes with an equal and opposite reaction. So since this box right here is pushing down on this surface right here, it makes sense that this surface is also pushing the box in this direction. Okay, so that force, that normal force, is going perpendicular. So normal force is always perpendicular to the body. Right? So since this body is lying on this surface right here, the normal force of this surface is this force right here. That is the normal force. Okay? And if we have friction, well, friction will be opposite always to our movement. So friction will be opposite to our movement, and since we are moving along this plane, we will have friction going in this direction. So friction, FR, force of friction. Okay? So we converted this system into something more, let's say, how do you say this? Into something more simplified. Okay, so we simplify this into all of the forces that are acting on our particle. Now that we know all of the forces right here, we can determine through this if we have, using Newton's second law of motion, if we have some sort of acceleration. Okay, acceleration in the x direction and acceleration in the y direction. We'll make an example of this, and we'll actually use this exact example. But I just wanted to tell you what the free body diagram is. A free body diagram is a reduction of a complex system into a more simplified system with all of the forces that are interacting with this object right now. I'll make a separate video on what the normal force and what the friction force is, so don't worry about that one, about these two things. But I just wanted to put it here so that it was a more complete example. Okay, so thank you for watching, and I'll see you on the next video.